A picture, they say, is worth 1,000 words. I would say a picture is worth 1,000 data points. In this video, we will explore various visuals. We would look at different pictures. Let's go away from the data, the numbers, and so on. Let's get into pictures. In this video, we'll look at how to describe our data visually. Now, data visualization is a completely different field entirely. People are well specialized on just visualizing data. It is a great skill to have. In this video, we'll look at how to construct frequency distributions, both manually, and later on in another video, I will show you how to create frequency distributions in Minitab as well. Well, I think I did show you in the introduction to Minitab, we created a histogram out of these frequency distributions. Now we'll look at how to construct and interpret a frequency histogram. We'll also look at how to develop and interpret joint frequency distributions, how to create what is called a relative frequency distribution. We'll also look at how to construct and interpret types of bar charts and also pie charts. And also we'll look at how to build a stem and leaf diagram. And lastly, I would also show you how to create line graphs, how to interpret trends in your data, and how to construct a scatter diagram and interpret it as well. That's the focus of today's this video. So this might go a little bit another long video as well. So enjoy, sit tight, and let's enjoy this conversation for those who are watching online and for those who are present out here. All right, let's go. Now, we are going to start by looking at how to create frequency distributions and histograms. But first, let's ask the question, what's a frequency distribution? So before we create it, what's a frequency distribution? It's a summary of a set of data that displays the number of observations in each of the distributions, distinct categories or classes. So it's a summary of a set of data. So a frequency distribution is a way to summarize our data. I would simply say that a frequency distribution is a table. It's a table that we use to describe our data. Now, so we could decide to collect a data of ages in the classroom right now. And let's assume that we did collect this data of ages, and let's say we have this distribution. So I'm going to create, so let's say we gathered this ages and we have this table, age, and we have the frequency. You guys are not right here for me to ask your ages, but I would randomly just say that in my class right now, I would 1, 2, 3, 4. I mean, how old are you? 18. So I have 4 students that are 18 years old. So my frequency counts, there are 4 students. What's their age? 18. So that's recorded. Now in my class again, there are 4 students that are 19 years old. Okay. There's only just 1 student that's 20 years old. Okay. What else can I find? Let me count. How old are you? You. There are 3 students that are 21 years old. Okay. 2 students that is 22 years old. What else do I find? 2 students, that's 23 years old. And there are 1 student, there's just 1 student that's 25 years old. Okay. So which 18, 19, 20, 21, 22, 23, 24. So there's 0 student that is 24 years old. So the age bracket of ages is between the minimum age is 18, the maximum age is 25. And this is the frequency counts. So we said that the frequency distribution is a summary of a set of data that displays the number of observations in each of the distribution's distinct categories or classes. So these are the distinct categories, or we can say classes, and so on. Okay. So what else can we look at? Now, if we want to know how many students are in the classroom, all we simply need to do is compute this column, and that will give us the total number of students in the classroom. So we have 4 plus 4 is 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I have 17 students in the class. So that's the total number of students here. So basically I have 17 students, and this is how we describe in the students in the classroom. So out of the 17 students, 4 students are 18, and 4 students are 19, 1 is 20, 3 students are 21, 2 is 22, 2 students are 23 years old, and just 1 student is 25 years old. That's how to describe this data using a frequency distribution. Now, these are discrete data. Why is this a discrete data? Because this data is countable. So data that can take a countable number of possible values are considered discrete data. So discrete data. So this example, we can call this student ages. So this is student ages. So this could be the title of my frequency distribution, a frequency distribution of student ages. Now, other example of discrete data we could have is, say, Walmart customer product categories, number of late deliveries per month, number of touchdowns scored per game, and so many other types of discrete data that are all available out there. Okay. Next, we're going to look at how to develop a frequency distribution for discrete data. So how do we develop a frequency distribution? Now, there are so many rules out there, so everybody has their rules. Usually I would say that come up with a frequency distribution that looks good. But what does look good mean? It's very subjective. Let's be a bit more constructive. Now, let's say we have let's look at create a list of possible values. Now let's go out of ages. Ages can be a little bit sensitive. So let's look at the number of late deliveries per month. Okay. Now let's say the first thing we need to do is list the possible values. So what are the possible values for number of deliveries per month? So I could have, say, 2. Let me just create a table to record all my data. So every day I'm recording some data. and 2, 1, 3, 2, 1, 0, and then I have 3, 5, 2, 1, 2, 3, 0, 3, 2, 2, 2, 4, 4, 2, 0, 1, 0, 1, 2, 3. Let me have one more row of data entry. So we have 3, 1, oh no, let's say 3, 2, 1. Clean this, doesn't look nice. 2, 1, 3, 2, 0. Okay. So we'll describe this. This is just raw data. And looking at this raw data doesn't really make any sense, you know? But now if I say that this is the number of late deliveries per month, now I really need to explain further what this data is. So the first step here is, first, we list the possible values. Now, what I was just doing here is what we call data entry. So there's something called, there are two types of errors that exist in, and let me just deviate a little bit. So talk about two types of errors. Now there's what is called the non-sampling errors. Non-sampling errors are where you make a mistake or enter a wrong detail. So when let's say I was going to enter 2 and I entered 3, that's a non-sampling error. And it's a very critical error because that can create a lot of outliers in our data or in our data sets. And the other type of error is called a sampling error, which we will talk about in the course of this course, sampling error. Now, what's a sampling error? A sampling error is basically the difference in terms of the characteristics of our population parameter and our sample statistics. We'll talk about that later on. We'll look at the sampling error for means and sampling errors for proportion. Now, let's not get too deep into, let's get back to our data entry. So first, we don't want to commit a non-sampling error, okay? So we want to minimize errors. So the first step is we list the possible errors. Now the next step is for us to count, is listing the possible values. And now the next step for us is to count the number of occurrences of each value. So here we recorded the number of late deliveries per month. And so we could have a column here, we call this late deliveries. And then we have another column we call the frequency. Now, when we look at this number, the minimum is 0. We have 1 all the way to 5. So we have 0, 1, 2, 3, 4, 5. Okay. Now, how many zeros are there? How many times do we have 0 late deliveries? This is 1, 2, 3, 4. What about 1? We have 1, 2, 3, 4, 5. What about 2? That's a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. What about 3? 1, 2, 3, 4, 5, 6, 7. What about 4? 1, 2. And 5 is just 1. Okay. Now again, if you want to verify that you had the right number, if you add all of this, what does that give you or give us? So that would be about 30, right? So this is 20 plus 10, so that's 30. And we can verify that this is 30. So how many rows, columns do we have? 1, 2, 3, 4, 5, 6. And how many rows do we have? 1, 2, 3, 4. 1, 2, 3, 4, 5. So 6 times 5 is equals to 30. So we have 30 data that we entered. That's how to verify that. Okay. You can see how simple statistics is. You know, at the end of this course, what I want to hear is that statistics is fun. So that's the motto of this course. Statistics is fun. You can tweet that, or yeah. And you can tag me as well when you do. All right, so we have these frequencies, and we can see that we have the total number of data point is 30. So what we say here, so this is the total number of observation. Our total number of observation, we represent it as n. So we have n is equals to 30. So n is also known as the sample size. So what's the size of our sample? So that's also known as the sample size. However, in this case, we're referring to the total number of observation. So that is our n. So basically, it's the sum of all these frequencies. So if this frequency is referred to as f of I, so where I goes from 0, 1, 2, 3, 4, 5. So our n is equals to the sum of, remember I told you that this means sum of, that's the big sigma. So it's the sum of the frequencies I, where I goes from 1 to k, where k is the total number of rows in this case. So k will be 1, 2, 3, 4, 5, 6. So from 1 to 6. And so k is a number of different values for the discrete variable. So the number of different values, and the number of different values we have for this discrete variable is 6. So what we are saying in essence is that the sum of I is equals to 1 to 6 of f of I in our case is equals to 30. Okay? So let this not scare you, all right? Now, we can also compute what is called a relative frequency. Now, with a relative frequency, we can basically know it's kind of a percentage, the percentage of each of this category in our data, or so it gives us more like a probability as well. Now, the relative frequency is basically equals to, again, let me define what it is. It's the proportion of total observations that are given in that are in each given category. So a relative frequency is basically f of I divided by n. So meaning that if I had a column here and I call this the relative frequency, now the relative frequency for the first one will be 4 divided by 30, 5 divided by 30, 11 divided by 30, 7 divided by 30, 2 divided by 30, and 1 divided by 30. So that's the relative frequency. Okay. Now, if you have your calculator, then you can do the computation. So 4 divided by 30, you can put it, I think it's about 0.133, and so on and so forth. So this column here gives us the relative frequency. So if I ask you to create the relative frequency distribution, that's the distribution of, that's data that you would compute. And for your relative frequencies, when you do the computation with your calculator, you can simply just round it to 3 decimal places. Okay? And then how do we interpret it? So let's say that I use my calculator. I actually have done this. So this is equals to, so 4 divided by 30 is equals to 0.133. How do we interpret this? So we can say that so this is about 13.3%. So as I said, you can express it as percentages as well, or as probabilities, which we'll get to later on. So here we can say during 13.3% of the months, the company had 0 late deliveries. During 13.3% of the months, the company had 0 deliveries. That's how we can interpret this data. And you can do the same. You can for the other columns as well. And so let's take another column. 1 divided by 30, you would also interpret it the same way. So that's the interpretation. Any questions so far? Okay. So what's next? Now, all of these, I'm also going to show you how to do all of these in Minitab as well. So we're going to enter all this data and create a histogram out of this data. So one of the things you can do already is, given this data that we see here, simply type everything in Minitab as I have shown you in. So in the headings will be late deliveries, frequency, relative frequency, and enter all of this data in each of the cell. And if you want to automate the process, you can create a formula that just does all the computation for you, referencing this column as well. So this is our frequency distribution that we have created by hand, and which you would get to learn how to do on a compute in Minitab. All right. So what's next? We are moving pretty well. How do we develop a frequency distribution for continuous data? How do we develop it? So there are different steps, as you would find in the course textbook. One of the things we try to do is determine the number of classes. So let's say so let me put it this way. So the steps. So I have my bullet points to guide me as we're going along. Developing frequency distribution for continuous data. You're welcome to take notes as we're going along, and ensure that you also read the chapters of the textbook. Now, what are the steps? 1, determine the number of classes. And we'll see what that means when we look at an example. Now, the next step is to establish the class width. What should be the width of the class? That's the next step. And then the next step would be, the third step would be to determine the class boundaries. Now, for the class width is basically the difference between 2 lower class limits, which I would explain later on. Now, for the class boundaries, we have the upper and the lower values of each boundaries. So we have the lower class limits, and we have the upper class limits. Now, the lower class limit is the smallest value belonging to a class, and the upper class limit is the largest value belonging to a class, which we would demonstrate shortly. And the fourth step is to determine the class frequency for each class. Determine the class frequency for each class. That is the number of data points in each class, the number of data points in each class. Okay, so these are the steps. Of course, these are so much text, so let's put it into practice. Now, like I said, how many classes should we have? How many classes? The first step, determine the number of classes. So there are different thresholds that we can explore, and the number of classes, if it's too few, then we might have what is called a wide class interval. If it's too many, we will have a narrow class interval. But we're going to use a rule of thumb to determine. So the question is, how many classes should we have? So given, for example, the data that we collected for the ages, how many classes should we have from that data? Now, there's a rule of thumb. So in your textbook, the rule of thumb is that you should have between 5 and 20 classes. So it sounds very arbitrary. Okay. However, the rule of thumb to use is we have 2 to the power of k is greater than or equals to n rule. So this is the rule we're going to use in this class. 2 to the power of k is greater than or equals to n. What is k? K is the number of classes. So k is the number of classes. That's what we want to determine. And so it's defined to be the smallest integer so that 2 to the power of k is greater than or equals to n. And of course, we know what n is. N is our sample size, okay? So n is the number of data values. All right. Now, so which means that if we look at the example we had above, where n is equals to 30, then what's 2 to the power of k greater than or equals to 30? So what should k be? Now, in case you do not know, so let's look at this. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is what? 8. 2 to the power of 4 is what? 16. 2 to the power of 5 is what? 32. Okay, so at this point, we can see that 32 is greater than or equals to 30. So which means that we are saying that 2 to the power of 5 is greater than or equals to 30. So the minimum value of k, so the smallest integer for k, so k could be 5, 6, 7, 8, but the smallest one is what we want to use. So our k will be equals to 5 in this case. All right. So if we know k, now the next thing we want to know is the class width. what should be our class width? So first we determine the number of classes, and in this, if we're using this example, we say the number of classes is 5. Now, what is the class width? The class width is equals to the maximum value, or the largest value. I would say the maximum value minus the minimum value divided by the number of classes, which is our K, the number of classes. So if we looked at our previous example here, the maximum value was what? 5. The minimum value is 0. So we're going to have 5 minus 0 divided by 5. So our class width will basically be 1. Okay. Well, we'll look at more examples that give us a bigger class width. All right. Let's explore this. So remember the rule of thumb, and I needed to create a much simpler example so it's easy for us to play around this whole concept. And I think I'm going to use this example that we had in the beginning for ages. Okay. So we have 17 here. So we have a total of 17 people of n. So basically, we are saying that 2 to the power of k is greater than or equals to 17. Now, 17 is a small data, so let's look at big data, because now that would give us a much smaller class here. But in case we wanted to create a distribution out of this data, realistically, so here, using this rule of thumb, so we would say basically k is equal to 5, because that's the minimum that we want to use as our rule of thumb. However, based on these, we can see that 2 to the minimum number of k would be 2 to the power of what? 2 to the power of 3 is 8. 2 to the power of 4 is 16. It's actually 2 to the power of 5 is greater than 17. So k is actually going to be equals to 5 in this case. So the number of classes that we're going to use is 5. So use 5 classes. I don't want to rewrite these numbers. Just keep writing towards the right. We have a very interesting infinite board. So first we determine the number of classes. And so from what we've seen from this data that we collected, the number of classes is equals to 5. Checked. So step 1. The next step, we want to establish the class width. So what's the class width? I will use W to represent the class width. The class width is equals to the maximum value minus the minimum value divided by the number of classes. And our maximum value here, the maximum age, is 25. Minus the minimum age is what? 18. Divided by the number of classes is 5. Okay? So now you can bring out your calculator to solve for this in order to determine the number of classes. So I'm going to bring up our calculator. Or I'm just going to bring up a calculator from my phone, so I don't keep moving around. Like I told you that you can use your phone as a calculator. And we have 25 minus 18. That gives us, we know it's 7. And so we have 7 divided by 5. And there you have to learn how to use the calculator, because if you don't use it correctly, you're going to have a wrong answer. So 7 divided by 5, we know it is going to be what? Who knows? About 1.4. It is 1.4. So if our class width is 1.4, now I would say we should round up to a nicer class width. Okay, so I would round it up to say 2. So we are saying that class width is 2 in this case. Okay, so basically you can round it up to a nicer class width. And then what do we do next? So now that we know that our class width is 2, now we're going to construct our class boundaries next. So I'm going to do it here. So the class boundaries. And we are basically starting from the minimum value, which means that we're starting from 18 to, so since our class width is 2, this is how you count it, 18, 19. So that's 2, okay? So we have 18 to 19. So that's a class width of 2, 18, 19. And then the next class width will be 20, 21, 22 to 23, 24 to 25. And how many number of classes do we have? We have 5 classes. So the next one will be 26 to 27. So 1, 2, 3, 4, 5. So we have 5 classes. Of course, our number stops at 25, so which means that this will pretty much be 0, flattened. But that's how to create the class boundaries based on the context of our example. If we had a different example, we'll have a different class boundary and class width. Now, in your textbook, you have various examples that you can take a look at in order to construct this class width. Now, based on these, what we're going to do next is now insert the frequencies. So we have here the frequency for each class. So if you look here, 18 to 19, how many? What's the frequency? 18 to 19. So that's the sum of these two. So that would be 4 plus 4, we have 8. 20 to 21, we add this, so that's 4. 22 to 23, we add this 2, there are 4 participants also. And 24 to 25, it's just 1 right there. So we have 1. 26 to 27 is simply 0, so you can delete that out, or just leave it at 0 there. Now again, if you add all of these numbers, 8 plus 4 plus 4, that's 16 plus 1, 17, we should have the same total number of students in my class. So here again, it's 17. So this is our frequency table, and this is how to create the class boundaries and so on. If you have any question, please remember on Fridays we have our Friday class huddles. Bring them up. We can look at more examples together. The best way to learn is by connecting and interacting and asking questions, and that's how you learn better. So far, I've shown you how to create a frequency distribution. Now, what else can you now create out of this? You can also create a relative frequency distribution. So let's call it RF for our relative frequency. And what would that be? I'm not going to do the math here with the calculator, but we know that this is going to be 8 divided by 17. This is going to be 4 divided by 17. And this is going to be 4 divided by 17, 1 divided by 17. And you might decide to just get rid of this column. We don't need this column. Okay. I'll just put it at 0. Okay. So we have, that's our relative frequency. Now, there's another type of frequency, which I'll talk about here, which is called the cumulative frequency. Cumulative frequency. What's a cumulative frequency? Now, the cumulative frequency is basically it's like a moving average of our frequency. So which means that the first cumulative frequency here is 8. The second one is 8 plus 4. 8 plus 4, that is 12. And the next one will be 12 plus 4, which is 16. And the last one is 16 plus 4, which is 17. So the very last value actually tells us the total number of participants. So when you create your cumulative frequency values, if the last number is not equals to this, the total number of frequency counts, then there's something that you've done wrong in your addition of the respective frequencies for each of the class categories. So that's how to create a cumulative frequency. And one other frequency table that is discussed in the textbook is the cumulative relative frequency for short. So cumulative relative frequency. Again, it's quite obvious what you're to do here. The first thing to do is to add all of this together. So here we have what? 8 plus 12 plus 16 plus 17, that is 53. Okay, so in the first one will be 8 divided by 53, 12 divided by 53, 16 divided by 53, and 17 divided by 53. Okay, so that's how to create the cumulative relative frequency. Oh, pardon, that's is actually not correct. So you still divide the cumulative frequencies actually by n. So it will still be 8 divided by 17, 12 divided by 17, 16 divided by 17, and 17 divided by 17. So the last value here should be 1 because your cumulative frequencies actually tends towards 1. That's so when we're looking at the relative frequency, it's more like a probability value. So when we get to the concept of probabilities, our probability shouldn't be greater than 1. And that's how we can check when there is an error. Yes, I just made an error, and the important thing is knowing how to fix your errors when you make the error. So far in this video, we have seen how to create a frequency table. We've seen how to create a relative frequency table. We've seen how to create a cumulative frequency table, and we've also seen how to create a cumulative relative frequency table as well. Okay, so we are doing pretty well because now we can start looking at some visuals. We're still looking at all this number. This chapter is about a picture. We said that picture is what 1,000 data points. So given these values that we have up here in this table, we can now start looking at how to create a frequency histogram. A frequency histogram. So a histogram basically is plotting our frequency table. Okay, so how do we go about it? So right here, we have this, the y-axis, and we have our x-axis. The horizontal axis contains the possible outcomes for the variable of interest, and the vertical axis shows the frequency for each possible outcome. Now, in a histogram, there are no gaps between the bars. In the video, when I showed you the introduction to Minitab, we created some histogram in that video, and you notice that there were no gaps between each of them. So let's look at this example we have here. We created these classes 18 to 19 and so on. So in this, so this is class boundaries, and this is our ages, student ages. Now I have, and of course I'm not starting from 0, so I'm assuming that this is 18, 19, 20, 21, 22, 23, 24, 25. All right, so our first class width is 18 to 19, and 18 to 19, we have, now in creating a histogram, we don't want to create any bar. So if I say 18 to 19 and I say put a value here, and then 20 to 21, I put the value of, let's just give an example like this, that is creating gaps. And that's not what we want. We want to ensure that there are no gaps. So in order to do that, we have to compute what is called the class boundaries as well, or the midpoints for each of the class. So what that means here is that for this first one, 18 to 19, we will start from 17.5 somewhere here, and then we'll end at 19.5 somewhere here. So I'm going to use blue for that. So this will be demarcated as our class range, and so we have 0 to 1 to 8. So I'm going to call this, so 1, 2, 3, 4, 5, 6, 7, 8. So 18 to 19, well, so that means we have all the way, we go all the way from up here. That's not so neat. And all the way here. And then 20 to 21 will be 19.5 to 21.5. And we have 4. So 1, 2, 3, 4, somewhere here, all the way to this point. And then 22 to 23 will be 21.5 all the way to 23.5, and we have 4 as well. So we draw this all the way to this point. And 24 to 25, we just have 1. And so that will stop at 25.5. And so we have this all the way to this point. So this is a frequency distribution of the students' ages. It's kind of skewed towards the right. So we say it's kind of right skewed. It's not symmetrical, okay? And we'll talk about what that means. And of course, we can decide also to create a frequency distribution for, we had other data points we looked at earlier. So we looked at the late deliveries. So you can also create a frequency distribution for that. I would leave that as an assignment for you all to try as well at home, and play around with different frequency distributions. And look at how to create and then how to create a histogram from the frequency distributions as well. Now, looking at our histogram, what does the histogram provide for us? There are many things the histogram provides. We can look at the distribution of our data. So it can show us where the center of our data is. It can also show us the spread of the data, and it can show us the shape of the data. And for the shape, we'll look at three types of distributions. We have distributions that could be left skewed, and distributions that are right skewed, or distributions that are symmetrical. So that's how we can describe the shape of the data. Okay, we are doing quite well. So we've looked at histogram, we've looked at frequency distributions. Next, let's move on to something different. Let's look at bar charts. So we've dealt with continuous numbers. Let's look at bar charts. So I'm going to create a big picture for us to remember how all of this works. If this would move upwards. Cool. We said in chapter 1 that we have two types of data. We have quantitative data, and we have categorical data or qualitative data. When you have a quantitative data, you can visualize the quantitative data using a histogram. After you've created your frequency and distribution, or you can use a stem and leaf plot, which I'll also show you before the end of this video. Stem and leaf plots. If you have a categorical data, then you can visualize it using a bar chart, which looks like a histogram. However, there are spaces between each categories, or we can visualize it using a pie chart. And of course, most people in the field of data visualizations prefer not to use a pie chart, so rather use a bar chart to visualize a categorical data than using a pie chart. Okay, so what's a bar chart? What's a bar chart? So a bar chart is a graphical representation of categorical data sets in which a rectangle or bar is drawn over each category or class. Now, I'll give a simple example here. Now, let's say I want to know where my students are living. So I have 5 students that live in Midland. I have 7 students that live in Bay City. And let's say I have 2 students that live in Detroit. So what I have done here is that we have this is a categorical data. So Midland, there are 5 students. Bay City, there's 7 students. Detroit, there are 2 students. Now, there is each of these levels have no particular order. So 7 is not more better than 5 or 2, and so on and so forth. So what this simply means is in this data, let's give it some heading. So location, and then here we have number of students. And what can we do here? We can simply create a bar chart in which we have, in our y-axis, we have the location, and in our x-axis, we have the location, x, and this is y. And in our y-axis, we have the number of students. Okay. And we have this as 1, 2, 3, 4, 5, 6, 7. Okay. Now, let's say I put this in alphabetical order. So base CD comes first. So B, and then Detroit next, D, and Midland next, M. Now for base CD, I have 7 students all the way up here. Now for Detroit, I have 2 students. You can see there's a space. The bars are not touching each other. And for Midland, I have 5 students. 1, 2, 3, 4, 5. So we're around here. But the bars are the same shape. So that's a bar chart. And of course, we can also use this same representation to create a pie chart by knowing what is the percentages of each of these categories. So we have 4 categories, and we find the percentages of each of these categories, and we can use that to create a pie chart. So this is how to create a bar chart, but a pie chart. So let's see if we can create a pie chart from this quickly. So a pie chart is a graph in the shape of a circle. Okay, so we used to show visually the parts of a total. So the circle is divided into slices, just like you have a pizza. You buy a pizza and then you divide it into different slices, and the bigger proportion is the one you give to me, and you guys take the smaller proportion of the pizza. Is that a good deal? I hope so. So what we need in order to construct our pie chart is to determine the percentages of each of these categories. Now, how do you determine the percentages? You simply, so let's call this, which I had space here. I don't write this again, so let's call this L, and number of students, okay. M for Midland, B for BCD, D for Detroit. So we have 5, 7, 2. Okay. So how many students do I have in my class here? So you add all of this together, and what does that give you? That gives us 14. So we have 14 students. Now you compute their relative frequencies. You all know how to compute the relative frequencies, don't you? So this is going to be 5 over 14, 7 over 14, 2 over 14. And then you compute their percentages. So let's use a calculator. 5 divided by 14 is 0.357. 7 divided by 14, 0.5, and 2 divided by 14, that's about 0.143. So we can see that Midland is about 35.7%. BCD, whole 50%, and Detroit, 14.3%. And if I should estimate this, so what I'm saying is that 50% of my students live in Bay City. That's half of it. So this is Bay City. And 35, so half of this is 25%, so 35 could be somewhere around here. So I'm saying 35.7% of my students live at in Midland. And then 14.3% of my students live in Detroit. So this is a pie chart. And as I said, the bigger part, if this is our pizza, and we call each of these slices the different CD, so you base CD is for me. All right. Wow, it's already an hour into this video. We are off to the last type of visualization that we need to cover for this chapter, and which is stem and leaf. Okay, so let's look at the stem and leaf plots, and then we would end this video. What is a stem and leaf plot? It's a way in which we use to visualize quantitative data, and you'll see what the benefit of a stem and leaf plot over a histogram. Now, when we looked at our histogram, given a histogram, if I asked you to tell me what the original raw data were, it's really hard to get back the original data from just looking at the histogram. You can just estimate what the data would be. However, with a stem and leaf plots, it's easy to derive our original data. Now, one of the things we do with a stem and leaf plot, the first thing to do is to sort the data from low to high. Now, and I will come up with some examples here to make it quick and easy. So let's say we have this ages 20, 18, 17, 15, 35, 14. Wow, I have a very young student in class, 28, 31. So let's assume this, we have 1, 2, 3, 4, 5, 6, 7, 8 students, and we want to create a stem and leaf plots. The first step is to sort this data from low to high. So which means we have 14, 15, 17, 18. So 14, 15, 17, 18, 20, 28, 31, and 35. So that's step one. Now, step two, you split the values into a stem and leaf. Now, what does that mean? So a leaf is equals to units place, and I'll explain what that means. And a stem is equals to all digits left off, all digits left of the units place. Of the units place. So for example, let's say we have for the value, I'm going to give a different value. For example, 113 is an example. The stem will be equals to 1, 1, 1, and the leaf is equals to 30. Okay, so we are keeping one digit for the leaf in this case. So we're keeping one digit for the leaf. So so the the third step is to list all possible stem from lowest to highest. So let's look at this in terms of the example I just gave you. So what we'll do here is group this. So we have all of this is one category, this is another category, and this is another category. So basically, we have 1 is our stem, we have 2 as our other stem, and we have 3 as our third stem. So we have 3 stems, 1, 2, and 3. Now, our leaves. So for 1, we have 4, 5, 7, and 8. Let's assume I had another student and I put here 35 again. So we have 2 students that are 35 years old. So I'm going to have 35 here as well. Okay. Now, next for 2s, we have 0, 8. And for 3s, we have 1, 5, 5. So if you have, so with this, we can clearly see that there's 2 students that are age 35. This is our stem and leaf plot. So our stem here is so our leaf is the units place, and our stem is all digits left of the units place. So this is our leaf. This is our leaf or our leaves, and this is our stem. So a stem and leaf plots. So the stem and leaf plots. Now, looking at the stem and leaf plot, it's easy for us to get back our raw data. So we can simply see that amongst between 10 to 20, we have 4 students that are between 10 that are less than 20 years old, and between 20 to 30, we have 2 students. And between 30 and above, we have 3 students. So it's by just counting the number of leaves from each stem. So that's how we can describe this data, just looking at the stem and leaf plots, basically. And we can also derive our original data. So we have 1, 4, so there's 14 years, 15 years, 17 years, 18 years, 20, 28, 31, 35, 35. This is something we cannot really derive right from looking at the histogram. So this is one of the benefits of having a stem and leaf plot. All right. So with this, I said we will come to the end, but before we end this video, I have just one more type of visualization that I just want to mention, and that's a scatter plot. I know I mentioned earlier that we'll look at that as well, and that's because at the end of our last chapter will be on simple linear regression, and there we'll look more at scatter plots. So let's talk about it before we end this video. Now, scatter plot is a way in which we can, it's a visualization that shows us the relationship between 2 quantitative variables, meaning that I might want to look at the relationship between, so let's say I sell a product and I have the price of a product, and I want to relate it with another quantitative variables. So let's say the number of items sold, or the quantity of items sold with the sales, or I want to relate, say, the sales of a product with the profits I'm making per product, so I can create a scatter plot to look at those differences. So we're talking about business here, so I'm trying to look at business examples. So let's say I have sales data in dollars. Yeah, in dollars. And then I have the profits I make. And let's say I have this column, I'll call it week. not week, not being weak, but week. Okay, so let's say I have week 1, week 2, week 3, and week 4, and so on and so forth. But let me just stop here. And my sales in week 1, let's say I made a sales of say $37,000, and I made a profit of $4,120. And then in week 2, I made a sales of say 38,000 with a profit of say 4,200. And week 3, sales of 40,000 with a profit of say 4,000. And in week 4, I made sales of say 50,000 with a profit of say 5,000, for example. Now, what we really want to look at is the trend of this relationship. No, this is 50,000. Okay, yeah, much better now. So we don't want to commit non-sampling errors. So we want to enter the right data. One of the things we can look at is by just looking at this. So we can have a scatter plot. So our y-axis will be our sales, and our x-axis will be our profits. And so we can look at that. Or we can look at the sales trend. So let's say first, we can look at the sales trend. How do we look at our sales trend? So basically we have sales versus the week. So we have week 1, 2, 3, 4, and then we have the sales values. And then we can, if we plot it well, we could see a trend that looks like this, that as the week increases, our sales actually increases. So we can say we have a positive trend. And we can also do the same for our profit. So we can have a profit trend. And also here we have the profits in the y-axis and the weeks in the x-axis. And so based on the data we got, we can see that as it was increasing and then suddenly it reduces a little bit and then increases, something like this. So we can kind of see the trend, how our profit is fluctuating from one week to the other. So that's how to look at the trend. And we can also plot the relationship between sales and profit to really see the scattered distribution of that. I would show you this when we get in Minitab, so it's easy for you to really digest. So we can, and I think with this, we have come to the end of this video. So a scatter plot could have something like this. So we have those data points, and then we can say, can we fit a line through this data to see that, oh, maybe there's a kind of a positive relationship between profit and sales. So as sales increases, profits also increases. That could be our final decision on that. All right, my target was to make this a 1 hour 20 minutes video, and I think we're right on target. So with these, we've covered so much. We've covered we've covered all that you really need to know in chapter 2 to be successful in this class. Now, as I said, if you have any questions, ensure you send me an email, you send a message on Microsoft Teams, which is what we're using for this class, or you reach out to me through different online platforms, on Twitter, on Instagram, everywhere. We are all online. But just ensure that you do not wait until it's too late before you reach out to your professor and also to your peers. And so with this, I will see you all in the next video.